Debbie Ray from Harris College of Nursing and Health Sciences. This is a faculty research symposium. We've been doing this for about 4 years now, maybe 5. We host these every, 3 months out of the fall semester and 3 months out of the spring semester on Fridays. This year I did a couple of things a little differently, and I think maybe that's helped to bring out more individuals. One is we put a schedule together that gives everybody the fall and the spring dates, so you can put those on your calendar. Second thing that we do is we put out an Outlook calendar reminder so that you can accept that and put that right on your schedule. The symposiums are here to introduce not only faculty research but also student research that might be going on. And in this case, it's a combination of a thesis with a faculty member. Up until this year, we've had about 20 people max, 25 max, come to these symposium sessions. So we're really glad to start seeing 40, 45 individuals here. You're more than welcome to come at any one of them. We order food to make sure that we have enough for everybody, so just make sure if you're coming to another one in the future, which is great for you to do that, RSVP and let me know you're coming. I knew that students were coming this time because faculty would let me know, and so that's a good thing. But we'd love for you to come back, and if you want to come back and a faculty member didn't tell you anything about it, but you want to be here anyway, feel free to come on. We will make room for everybody that wants to be here. The sessions will start up again in January, and there will be a January, a February, and a March session as well. If you want a calendar outlook for it, the bookmarks, we have them over in Harris College in the Dean's office, up on a desk, and then we also have them in each of the departments, so you can feel free to go by and get one of those so you know when the future ones are. Today, without any further ado, I'm going to introduce Dr. Meena Shah. She's in the kinesiology department. She is our nutrition and physical activity specialist, and she does quite a bit of research in varied elements, from adults to youth to whoever, on different aspects of nutrition with disease many times, or with physical activity patterns. This particular study is exciting because it's gotten a lot of national and international press. And so I thought, this would be a great way for people to be able to see here at TCU what others are recognizing about one of our own faculty members. So without further ado, Dr. Meena Shah.
Thank you, Dr. Ray, and thank you all for coming. Gosh, what a big turnout. So the topic of my presentation today is the effect of menu labels on calories loaded and consumed in young adults, and this was a randomized control trial. This was a study that was conducted by Ashley James, a graduate student in the Department of Kinesiology. She graduated last year. So eating out is very popular amongst American adults, and on average we eat out 5 times a week. And when we look at trends in how we spend our food budget, currently we're spending nearly 50% of our food budget on eating out, as opposed to only 26% in 1960. Eating out in fast food restaurants is associated with a number of problems. It's associated with increased energy intake, increased calorie density, poor diet quality, and obesity. It is very difficult to estimate the calorie content of restaurant foods. Several investigators have looked at this and have found that most subjects, including dietitians, will underestimate the energy and fat content of restaurant foods. So because of these issues, calorie posting on menus has been proposed as a potential strategy to control energy intake. And in fact, the recent Healthcare Act states that any restaurant with more than 20 outlets must disclose calorie content of food items on menus within a certain period of time. So what is the evidence for, is this effective, posting calories on menus? Is it effective? So let's look at the evidence. So there have been about 20 studies that have looked at the effect of calorie posting on menus on calories ordered. And the results have been conflicting. About 50% of the studies have found that posting calories on menus reduces the number of calories ordered, and the other 50% have found no such effect. Only a few studies have looked at the effect of calorie posting on menus on calories consumed. And of the 4 studies that looked at this, only 1 study found that posting calories on menus will reduce the number of calories consumed. So what are the possible reasons for the mixed findings? Many individuals have difficulty appraising the calorie content of food items. So what does the calorie content mean? For example, what does 500 calories mean? What does it mean in the context of your total energy needs? Do they know what their total energy needs are? And even if they knew what their total energy needs are, there would be some mathematical processing that would be required to figure out, okay, this makes up about 25% of my total daily needs. And many people have a hard time doing that. So we need a strategy that is easier to relate to in order to reduce the number of calories from restaurant foods. And the exercise equivalent of food calories, that is the amount of exercise needed to burn the food calories, may be a potential strategy and easier to relate to. There have been 2 studies on exercise posting that have been published recently, and they were published after we began our study, so our hypotheses are not based on those studies. The first one by Wright et al. Looked at the effect of exercise and calorie labels on purchases of sugar-sweetened beverages, and they did this study in corner grocery stores amongst Black youth. And the labels were placed on soda crates. And they had 3 groups. One group was showing the beverage calories, the labels to show the beverage calorie content. The second group was showing beverage calories as a percentage of their total daily needs, and then the third group was showing minutes of jogging required to burn the food calories of their beverage calories. And the results showed that it was the exercise labels that helped to reduce the number of calories purchased from beverages. The limitation of this study was that it did not look at the number of calories consumed from beverages. The second study on exercise posting by Ray et al. Looked at the effect of calorie and exercise levels of calories consumed, ordered. And the subjects were randomized to one of 4 menu groups. The first 2 were either miles of walking to burn the food calories or minutes of walking to burn the food calories plus calorie labels. The third one was just calorie labels, and the fourth one was no labels, just the food items, nothing else. And the results showed that it was the first menu, which is miles of walking to burn the food calories plus calorie labels, that was effective in reducing the number of calories ordered compared to the control menu. The limitation of this study was that it did not look at the number of calories consumed or prospective food consumption. So the purpose of our study was to look at the effect of menus with exercise labels, calorie labels or no labels on calories ordered and consumed at lunch, and prospective post-lunch energy intake. Our hypotheses were that exercise labels will lead to fewer calories ordered and consumed compared to no labels. Calorie labels will lead to fewer calories ordered and consumed compared to no labels. There would be no difference between the exercise labels and the calorie labels regards calories ordered and consumed, and there would be no difference in post-lunch or prospective energy consumption by menu type. We recruited 300 subjects, including 133 males and 167 females. All of them were 18 to 30 years old. The subjects were recruited in a number of different ways, by word of mouth, by flyers placed around campus. We placed flyers on almost every bathroom on campus, including the bathroom stalls. We also recruited through classroom announcements and university newsletters. We had a number of exclusion criteria. We excluded potential participants who had taken an upper-level course in nutrition and dietetics. We excluded those individuals because we felt like they would know too much about nutrition and the menu label would have no effect on their food choices. We also excluded potential participants who were exercising excessively, and we did that because people who exercise excessively have very high energy needs, and so we felt like the menus would have no impact on their energy needs. We also excluded subjects who are potential participants who are taking medications that affect appetite, eating disorders, dieting, those who are vegetarians, with food allergies, and pregnancy and lactation. We screened 502 subjects for eligibility. Of these, 202 were excluded. And most of the exclusion were because they were exercising too much or had taken an upper level course in nutrition or dietetics. So we ended up with 300 subjects who were eligible for this study. The eligible participants were randomly assigned to one of three menu conditions: the no labels menu, the calorie labels menu, and the exercise labels menu. Each menu contained had about 100 subjects. And the randomization was stratified by sex and BMI. And participants were blinded to the purpose of the study. They were told that we were looking at the effect of the meal on hunger and fullness. So the no calorie labels menu was the control menu and contained just the food items without any calorie information or exercise information on it. The calorie labels menu displayed the calorie content of the foods next to each food item and a statement on the energy needs for men and women. We stated that men need roughly 2,400 kilograms per day and women need approximately 2,000 kilograms per day. The exercise labels menu displayed the minutes of brisk walking needed to burn the calories. And this menu was developed separately by gender because of gender differences in body size and energy expenditure. So the minutes of brisk walking needed to burn the food calories for each food item was based on the average national weights for men and women and the energy expenditure that corresponds to a walking speed of 3.5 miles per hour. So what we ended up was, so if an average male exercised or walked at 3.5 miles per hour, he would be burning 7.3 kilocalories per minute. An average weight woman would burn 6.1 kilocalories per minute. So I've got an example here of a particular food. It's a quarter-pound cheeseburger, which was one of the food choices, and this contained about more than 700 kilocalories. And so it would take an average size female weighing about 71 kilograms, 2 hours of brisk walking at 3.5 miles per hour in order to burn the calories from that particular food item. Are you guys worried about what you're eating? All three menus contain the same food and beverage options and a wide selection of fat and calorie content. We had 8 choices of burgers, several choices of chicken sandwiches, chicken nuggets, chicken strips, salads, sides including several different serving sizes of French fries, condiments, desserts, several choices of sodas, and water. Lunch was scheduled within 30 minutes of each subject's usual eating at lunchtime, and we asked them to control their food and beverage intake prior to lunch. So they were asked to eat their breakfast at least 3 hours prior to lunch, and then they were not allowed to eat anything between breakfast and lunch. They were allowed to drink water, but they were not allowed to drink any water 1 hour prior to lunch. We also asked them to control their physical activity level prior to lunch, and they were allowed to exercise up to 30 minutes of vigorous intensity exercise or 60 minutes of moderate intensity exercise. And these conditions were verified before beginning the study, and then height and weight was measured. And each subject was seated in a private space in the metabolic laboratory in the Department of Kinesiology. And we have several cubicles there, so these cubicles were divided by these plastic dividers so the subjects couldn't see each other. So some of the subjects were seated in those cubicles, and then we have several tables in the metabolic lab, and so some of the subjects were seated at their own tables. None of the subjects were facing each other because they were not allowed to talk to each other. So once they were seated, they were provided with the menu that they were randomized to, and then they were asked to circle whatever they would like to eat. They were also told that no leftovers would be taken home. And here's a pretend subject circling some of the menu items. Here's the IRB people right here, so be very careful. And notice the flowers. We had flowers on every table. Try to make it a little bit nicer. So the food was purchased from a local restaurant. It wasn't very far, just within a few minutes of walking distance. And the subjects completed questionnaires once the food arrived. And once the food arrived, it was weighed and placed on standardized paper plates before being served. And the selected beverages were also weighed and poured into appropriate size cups depending on what they ordered. And the leftover food and drinks were also ordered. And all the weighing took place covertly behind the screen, so the subjects didn't realize we were doing all of this stuff. And we weighed our food using digital scales, which was accurate to the 2.5 grams. And then the calorie content of the food and drinks ordered and consumed was assessed or calculated using data from the fast food website. We also assessed perceived hunger, fullness, desire to eat, and thirst levels. And this was done using validated 100 millimeter visual analog scales. And this was done before the meal began and at meal completion. We also assessed perceived meal palatability using the same type of scale, and this was done 1 minute after the start of the meal and immediately following the meal. The next day we administered a food recall to see what they had consumed after they left the lab during the rest of the day, so that was a prospective or post-lunch consumption. And then the subjects in the calorie labels and exercise labels were also asked if they had noticed the labels. So we did a one-way analysis of variance to look at the effect of menu type on perceived levels of hunger, fullness, desire to eat and thirst, pre and post meal, and then palatability. Analysis of covariance was used to examine the effect of the menu condition on the main output variables. And there were lunch calories ordered and consumed, composition of the lunch calories ordered and consumed, and prospective post-lunch calories consumed. And the main analyses were adjusted for pre-meal hunger level and sex. And we adjusted for the pre-meal hunger level because even though we randomly assigned our subjects to one of the 3 menu conditions, there were differences in pre-meal hunger levels. I think the exercise labels group was more hungry pre-meal compared to the control condition. We also adjusted the data for sex because men could order and consume more calories compared to women. And then the differences between the menu conditions were evaluated by post-hoc analysis, specifically least square means. And the data were analyzed using the SAS statistical package. So going to results next. This first slide shows demographic characteristics by menu condition. And we had about 10% more females than males across all 3 menu conditions. Most of our subjects were white, most of them were non-Hispanics, and most of them were college students. The mean age was about 22, and the mean BMI was about 24 kilograms per meter square. And none of these variables were significantly different by menu condition. This next slide shows the behavioral characteristics by menu condition. And on average, our subjects consumed 2.3 meals, fast food meals per week, and this was not different by menu condition. And dietary restraint, disinhibition, and hunger, these were assessed by the 3-factor eating questionnaire, and these were also not different by menu condition, so our randomization seemed to have worked pretty well. This next slide shows perceived hunger, perceived levels of hunger, fullness, desire to eat and thirst, pre and post meal, and palatability by menu condition. And there was no main effect of menu condition for any of these variables except post meal fullness, which was significant. And then post hoc analysis, specifically least square means, showed that pre-meal hunger levels were significantly higher in the exercise labels group compared to the no labels group. And this is the reason why we adjusted for the pre-meal hunger levels. And then post-meal hunger levels were significantly lower in the post-meal fullness levels were significantly lower in the exercise labels group compared to the no labels group. This next slide shows the calorie ordered by menu type or menu condition. The red bar represents the no labels group. The yellow bar represents the calorie labels group, and the green bar represents the exercise labels group. And we had a significant main effect of menu type on the number of calories ordered. And when I did the post hoc analysis, we saw that the exercise labels group consumed ordered 140 fewer calories compared to the no labels group, and this was statistically significant. There was no difference between the calorie labels group or the no labels group, or between the exercise labels group and the calorie labels group. And then this next slide, shows the calories ordered by menu type, and there was a significant main effect of menu type on calories ordered. I'm sorry, I haven't. Okay. I think we're on the right slide now. I'm trying to match what I'm looking at here to that. Okay, so this slide shows calories consumed by menu type, and there is a significant main effect of menu type on the number of calories consumed. And this is really our main outcome variable. And so that was significant. And when we did the post hoc analysis, we found that the exercise labels group consumed about 100 calories fewer than the no labels group, and this was statistically significant. There was no difference between the calorie labels group and the no labels group, or between the exercise labels group and the calorie labels group. All right, this next slide shows the diet composition of the food ordered and consumed at lunchtime by menu condition. And there was a significant main effect of menu type for percent calories ordered from fat, but not for percent calories ordered from consumed from fat. So when I did the post hoc analysis, I found that percent calories ordered from fat and consumed from fat were significantly lower in the exercise labels menu group compared to the no labels menu group. There was no difference between the no labels and the calorie labels, or between the calorie labels and the exercise labels. And then percent calories ordered and consumed from carbohydrates or ordered and consumed from protein were not different by menu condition. This next slide shows prospective post-lunch calories consumed, and there was no main effect of menu condition on what they had later on in the day, which indicates that, so even though the exercise labels group consumed less calories at lunchtime compared to the no labels group, they did not compensate for that later on in the day by eating more food compared to the no calorie labels group. And then this next slide shows percent of subjects who noticed the labels in the calorie labels group and the exercise labels group. And approximately 85% to 90% of the subjects in these two groups have noticed the labels, and there's no difference in the percent who noticed the labels between these two groups. Our study has several limitations. We studied young adults only, and they were mostly non-Hispanic white college students. And so the results cannot be generalizable to the American population. We also conducted our study in a laboratory setting. We tested only one meal, so we don't know if the results will be sustained over a longer period of time. And then we provided no price information on the menus, and we know that price has an influence on what people order and consume. We had several strengths. This was the first study that had investigated the effect of exercise labels on calories consumed. It was a randomized control study, so it was a gold standard study. And we measured prospective or post-lunch food intake. Most of the other studies did not do that. Our menus contained a variety of food choices with a wide selection of energy and fat content, and we measured height and weight. Most of the other studies did not measure height and weight. They got reported height and weight, and reported height tends to be over-reported, and reported weight tends to be under-reported, so it's not very accurate. So in conclusion, the exercise labels menu led to fewer calories ordered and consumed compared to the no labels menu. There was no difference between the calorie labels menu and the no labels menu, and there was no difference between the exercise labels menu and the calorie labels menu. There was also no difference in prospective food consumption by menu type. Future studies need to be done in a more diverse population, including different age groups and ethnicities and races, so that the results can be generalizable. We also need to do future studies in natural settings like food courts, and I think Brooke is interested in doing that. She's one of the graduate students here this year, and she's very interested in that. We also need to evaluate effects of labels over several meals to see if the results can be sustainable. We need to provide price information and possibly a budget. Maybe the budget could be something what a typical person spends at a fast food restaurant, maybe $10 out of that, have to work it out. And then we also need a combination group which would include both exercise labels and calorie labels. I would like to acknowledge a number of individuals, Dr. Joel Mitchell and Dr. Linda. They were Ashley's thesis committee members, and they provided valuable comments regarding the design of the study as well as the results. I'd also like to thank Beverly Adams Hewitt. She's a statistician at UT Southwestern Medical Center, and she provided us with statistical consultation. Kelly Crisp and Marcel Turner, I don't know if they're here, but they put a lot of work into this project. There were several other students who also helped out. There was Heather Eepner, a graduate student, and then all the remaining students are undergraduates that have graduated. Mike Gasper, Sarah Jokul, Jessica Bowman, Nicole Toomey, and Eric Glasgow. We presented our findings orally at the American Society for Nutrition. This is part of a very, very large meeting, the Experimental Biology meeting in Boston, Massachusetts, this April. And it was actually right after the Boston bombing, so we didn't even know whether we would be able to present, but we were really lucky we were able to present. And Ashley's expanded abstract won the second place award at the Nutrition Education Research intersection, and she was competing against PhD students, and she won the second place award, so we were really proud about that. And there's our picture right there. So, thank you very much, and questions? I guess I've answered all your questions. Explained everything so thoroughly that I answered. Yes?
On your previous research, didn't you find that the time distance for exercising affected more than time?
Yes.
Why did you end up using time?
Well, that study was actually published after we started our study. So our design was not, or our hypotheses were not based on that study.
Oh.
Yeah, it sucks that they published it. It really sucks because they just published their data. Yeah. Yes.
What was the budget for this study?
What was the budget? We probably spent, I would say, $1,500 to $2,000 on the study. So we spent roughly about $10 per person. Actually, no, that doesn't make sense. 10 times 3 is 3,000, right? We must have spent less than that. So we may have spent $7 or $8 per person. But some of our subjects really consume a lot.
Is there any compensation for the participants? Like a gift card?
No, we
they don't get anything.
we actually, yes, we did have a gift card when we were trying to recruit. But it was not a big deal. It was just a small one because we were getting to a point where it was harder and harder to recruit people. So we offered a small gift. I don't even remember the amount, but that was just later on. It was just probably about $20 or so. I can't remember. And it was like you win it, you not necessarily get it, you know. Chances of getting it are very slim, which we didn't tell them.
Is there a trait for participants who agree to the study? Do they have something in common that might distinguish this population? Like they think it's cool or is there any bias for volunteers who love this idea?
Well, you know, as far as we actually didn't collect data on people who told us they were not interested. So I really can't comment on that, whether there is a bias or not. We did have data on 500 people, you know, figuring out, okay, are they eligible or not, but it was nothing beyond, you know, what I put down on my eligibility criteria. So it wasn't like, were they more motivated, you know, what grades were they, you know, were they junior, senior, all that kind of stuff. I didn't have any of that information to really give you a sense of the ones who participated, were they more motivated compared to the others who did not. So it's a very good question, but I don't think I can answer that because I don't have the data to answer that question. But our subjects, I'm sorry, go ahead.
Yeah, but you have groups and you randomize.
Yeah. Yeah, we did randomize. Randomization was pretty good because we randomized by sex as well as BMI. So our groups turned out to be very equal as far as sex and BMI is concerned.
So the reason I asked was when my daughter was in college and I ran into one of my friends and my daughter said he's a professional participant. He got paid for nutrition. He get paid for studying like a 4,000 calorie study, and he enjoys it because he get to eat. I just want to share some tips.
Well, you know that I'm sure we had participants who were there because they could get a free. I'm sure there's someone that might for that reason. So I can't discount that. And so they might be different as a group compared to the ones who decided not to participate. Maybe even socioeconomic differences, you know, the ones who decided to participate compared to the ones who didn't. So our sample is definitely not generalized.
As far as the food that they ordered, what they received, you did measure whether they liked that food or not, whether it tasted good to them.
Yeah, we assessed that palatability.
And so when you looked at the comparison of the groups, was there anything that stood out to you that some just didn't like what they were eating and so they ate less, or was that really taken?
We just had one measure of palatability, which was before the meal, 1 minute after the meal started and at the end of the meal. And it was just a single measurement. It didn't ask, that's it. So I really wouldn't be able to answer that question, whether some foods they liked more than others. Because obviously, yes, they were getting a whole bunch of foods. You know, they might order a burger and a drink and a dessert. Did they like it all? That's what our question was. We didn't say, did you like all the individual items?
Would that be something that you might consider a teacher study, where because of palatability, maybe they didn't eat a certain thing, but it wasn't because of the calories or the exercise, they just didn't like it?
I don't know. I think, you know, Brooke and I were talking about it. She's going to try and do hers in a food court if possible. And it's going to be